Hello. Today I would like to talk about spontaneity with regards to chemical reactions and determining whether or not a reaction will be spontaneous. And we're going to use the equation delta G equals delta H minus T delta S in order to do this. Now, I am assuming that you already know what delta H is, that is enthalpy, and how to calculate it and what the sign of delta H means. So, a little review. Delta H is enthalpy. If it is positive, that means energy is being absorbed. If it is negative, that means energy is being given off or emitted. And capital T is temperature, that must be in Kelvin. And delta S is entropy. Entropy is if delta S comes out to be positive, that means entropy of the system is increasing. And if delta S is negative, that means entropy of the system or the reaction is decreasing. So the signs are the most important, really. We're looking at the signs of delta H, delta S, and then we're going to calculate delta G, which we'll talk about in a minute, is Gibbs free energy. Okay, so first, just spontaneity in general, when it refers to a chemical reaction, whether it's spontaneous or not. That means a reaction that will occur all by itself without a continuous input of energy. So most combustion reactions are spontaneous. Now, they might need a spark to get them started, but once they're going, you don't have to put in any more energy. So you could still need a spark, and that would still be considered spontaneous as long as you don't have to keep putting energy in to make the reaction occur. So other reactions, if you mix together, very common baking soda and vinegar, whatever. Now that one, instantaneously, you'll see a reaction. But spontaneity does not say anything about the rate. It's not necessarily an instantaneous reaction. It could take days or months or even years to occur, but if it occurs by itself without a continuous input of energy, then it's spontaneous. And for a given set of conditions, a reaction that's spontaneous in the forward direction will not be spontaneous in the reverse reaction. Okay. And the fourth statement is that chemical reactions will proceed with a change in enthalpy and entropy. And for the system, neither a decrease in delta H, so delta H being negative, giving off energy, nor an increase in delta S alone, increasing in entropy for the system, neither one of those by themselves can determine spontaneity when we're looking at the system. And so that is where this delta G will come in. Delta G is giving us the criteria for whether or not a reaction is spontaneous or not at constant pressure and temperature. So delta G, called Gibbs free energy, it's a measure of spontaneity and is also it's a measure of the useful energy available from that reaction. So today we're really concentrating on the sign of delta G. If delta G is negative in your calculation, that means it is spontaneous in the forward direction. If delta G is 0, that means the reaction's at equilibrium. If delta G comes out to be positive, that means the reaction is not spontaneous in the forward direction, but it would be spontaneous in the reverse direction. So for a reaction like this, when solid NH4SCN is mixed with solid BaOH2 in a closed container, the temperature drops and a gas is produced. Which of the following indicates the correct signs for delta G, delta H, and delta S? Okay, well, as we read that little statement, it says the two things are mixed together and a reaction happens. Okay, so that's definitely spontaneous. So we know then that delta G has to be negative if it's spontaneous. So it has to be one of these three. We can ignore those. Okay. Secondly, it says the temperature drops. Now, we're measuring the temperature of the system. If the temperature is, or actually, I'm sorry, we're measuring the temperature of the surroundings. if the temperature is dropping, that means that the system is absorbing energy from the surroundings. So anytime we're measuring a temperature drop, then we know that energy is going in, enthalpy is going to be positive. Energy is going into the system. So delta H is positive. So that gets rid of this one. And then finally, it says that delta S is, or we need to know the sign of delta S. So it says a gas is produced. So we mix together two solids and a gas is produced. So we know that entropy is increasing. And so our correct answer would be C. Okay, so now looking at delta G calculation, we can use this equation. Delta G is delta H minus T times delta S. So this is going to calculate delta G for S at a specific temperature, or sometimes we just also, again, are looking at the signs. When you're actually calculating, you have to watch your units. Delta H is usually given in kilojoules. Delta S, however, is usually given in joules per Kelvin, and then temperature must be in Kelvin. So then our delta G is usually calculated in kilojoules. So we'll do an example of that. We're going to look at some questions now from past Olympiads. So question 24 from the 2008 local exam. For a reaction at 25 degrees Celsius, delta G is negative 33.3 kilojoules, delta S is negative 198 joules per Kelvin. What is the value of delta H? Okay, so for our equation, delta G equals delta H minus T delta S. So we're given delta G, it's negative 33.3 kilojoules. What we don't have and what we're looking for is delta H, so that's X. We do have temperature, but that's given in Celsius, so adding 273 to that gives us 298 Kelvin. We can plug in 298 Kelvin. And then our S is in joules per Kelvin. We need to put that in kilojoules, so we're going to divide that by 1,000 to get negative 0.198 kilojoules per Kelvin. So we will plug that in. I ran out of room here for Kelvin. Okay, so if I multiply those together, I'm going to get negative 59 kilojoules. And so I have X plus 59. So I'm going to subtract the 59 to the other side. And I'm going to get X equals negative 92.3 kilojoules. So A is the correct answer. Okay, in the second problem, it gives us another reaction. Solid silver plus oxygen gas gives solid silver oxide. It tells us it's exothermic. Now the questions are, or the answer possibilities are, it is spontaneous at all temperatures. It's spontaneous only at low temperatures. It's spontaneous only at high temperatures. It's not spontaneous at any temperature. So once again, using the delta G equals delta H minus T delta S equation, plugging in what we know, we can figure out what would the temperature need to be in order to tell whether or not it's going to be spontaneous. So we need to look at the signs. So if we have, it's exothermic, so we know delta H is negative. No matter what, we know temperature is going to be positive because it's in Kelvin. And now delta S, for this reaction, we have a solid and a gas going to all solid. So in this case, entropy would be decreasing, so it is negative. So mathematically, we have a minus, and then we have minus, and then these two multiplied together would be negative overall. So a minus and a minus make a plus. So we have delta H is negative and then this term will be positive. So if this term is larger than the delta H, that would make our delta G positive. If this term is less than the delta H, then the delta G term would be negative. So we know that low temperatures would make this term smaller, high temperatures would make this term larger. So we need it to be low temperature so that this T delta S term is less than the delta H, so that our delta G will be negative. Okay, so the only way it's going to be spontaneous is if our temperature is low. So the correct answer would be B. Okay, another question from a past Olympiad. This is from the 2005 local exam. For this reaction, N2H4 liquid goes to N2 plus 2H2 gas. Delta H is minus 50.6 kilojoules. Once again, we have these choices: is it spontaneous at all temperatures, non-spontaneous at all temperatures, spontaneous only at low, spontaneous only at high. So once again, just thinking about this equation and thinking about what the signs will be, we'll be able to answer that question. So we know that delta H is negative. And now in this one, we have a liquid going to a gas. So we know that our entropy is positive and always our temperature is positive. So we have a minus for the delta H, subtracting this term. So no matter what temperature is, it's just going to get more negative. So this would mean that no matter, or at all temperatures, delta G will be negative. So it will be spontaneous at all temperatures. Okay, so delta H being negative, delta S being positive, so it's being exothermic and increasing in entropy, it will always be spontaneous. Okay, and a fourth question from the 2011 Olympiad test, the local exam: which of the following sets of conditions would result in a reaction that is spontaneous at high temperatures but non-spontaneous at low temperatures? Again, just looking at this equation, so looking at many past exams, there are very, very, very often questions just with this one equation, either solving for something or plugging in possible conditions and seeing like these, what would the temperature be? So we want to know when it would be spontaneous at high but non-spontaneous at low. All right, so our first choice, if delta H is positive and delta S is positive. Okay, and again, we know that temperature is always positive in Kelvin. So in this case, in order to get delta G to be negative, this term would need to be larger in order to get a negative mathematically. So that means at high temperatures, it's spontaneous. On the other hand, if this term is lower, then a plus minus a smaller plus, it's still going to be plus over all, so that would be non-spontaneous. Okay, so in this case, this question saying when would it be spontaneous at high and non-spontaneous at low? That's the answer. Those are your conditions. Okay, so the answer would definitely be A. Just looking at the other possibilities, if delta H is positive and delta S is negative, okay, which is B, so again, plugging in those values. So if delta H is positive, but delta S is negative, then we have a plus and a plus. So in this case, no matter what, it is not spontaneous. It's not spontaneous at any temperature, because we're adding together two positive numbers. So B is never spontaneous. When delta H is positive, endothermic, and delta S for this system or reaction is negative, so entropy is decreasing, it's never spontaneous. Okay. For C, we have if delta H is negative and delta S is negative, when they're both negative. So in this case, if delta H is negative and delta S is negative, then once again we have a minus a negative, so that would be a plus. So this was like that other example. If the temperature is low, then this term could be low enough that it wouldn't cancel out the negative delta H. So it would be spontaneous at low temperatures. If temperature is high, then this positive could cancel out that negative, and then it would not be spontaneous. So this is just the opposite of what it's asking for in the question. And then D, the choices are if delta H is negative and delta S is positive. And again, in that case, it would be just like the other one that we have a negative minus a positive, so it would be just getting higher negative no matter what the temperature. So this one would be always spontaneous at any temperature. Okay, so again, knowing what the signs are, if you actually have to calculate, make sure you watch your units, and otherwise just playing around with the signs and figuring out when you can make delta G negative, under what conditions. Those are the most common type of questions with delta G and spontaneity on the Olympiad. So there is a quiz for you to try some questions reviewing these concepts.